Hi my dear students, welcome back to our amazing YouTube channel of Brilliant Katha. This is the third recap lecture in JEE Mantra Series, and in this lecture we are going to cover trigonometry, properties of triangles and inverse trigonometric functions. First we start with trigonometry. Starting with the basic formulae from trigonometry, as you know there are 6 trigonometric functions: sine, cosine, tangent, secant, cosecant, cotangent. Among all these 6 trigonometric functions, 3 are reciprocal to the other, and tan and cot can also be expressed as the ratio of sine and cos, whether it is sine by cos is tan and cos by sine is cotangent. Now starting with, so sine and cosecant are reciprocal to each other. Sine into cosecant is equals to 1, cos into secant is 1, tan into cot is 1. Tan is sine by cos, cot is cos over sine. And 3 trigonometric identities that we have are sin square theta plus cos square theta is 1, secant square theta minus tan square theta 1. From secant square minus tan square 1, we can express it as secant square is equals to 1 plus tan square, or tan square is equals to secant square minus 1. From this we can also say one more important trigonometric identity is secant square minus tan square equals to 1. This is of the form a square minus b square, so we can write it as a plus b into a minus b. So secant theta plus tan theta and secant theta minus tan theta are reciprocal to each other. Whenever you come across secant theta plus tan theta, immediately take the expression secant theta minus tan theta, which is reciprocal of the given part. So in the same way, third identity that we have is cosecant square minus cot square is theta. So cosecant square is 1 plus cot square theta, and cot square theta is cosecant square theta minus 1. Same as I said, cosecant theta plus cot and cosecant minus cot are reciprocal to each other. Secant plus tan and secant minus tan are reciprocal to each other. Next, signs of trigonometric functions in different quadrants. You know we have 4 quadrants. Quadrant 1, which is bounded by positive x-axis, positive y-axis. Quadrant 2, negative x-axis, positive y-axis. And quadrant 3, negative x-axis, negative y-axis. Quadrant 4, positive x-axis, negative y-axis. So in quadrant 1, all the 6 trigonometric functions are positive. In quadrant 2, only sine and its reciprocal cosecant are positive. In quadrant 3, tan and its reciprocal cot are positive. In quadrant 4, cos and its reciprocal secant are positive. Why sine and cosecant are positive in quadrant 2? Why tan and cot are positive in quadrant 3? Why only cos and secant are positive in quadrant 4? We have already discussed in sessions itself. So just as this is a recap session, I am just revising it. So this gives us the what are all the trigonometric functions which are positive in respective quadrants. Next, trigonometric functions of allied angles. First we will understand what is an allied angle. For an angle theta, an angle alpha is said to be an allied angle if and only if either theta plus alpha or theta minus alpha, is a multiple of pi by 2. So for any angle theta, an angle alpha is said to be an allied angle if either this or this, that means either sum or difference, should be a multiple of pi by 2 for all n belongs to z. Suppose if you take an angle 30, for 30 degree, what are all the allied angles? Minus 30 will be an allied angle. Why? Because when you add 30 and minus 30, you get 0. 0, you get n pi by 2 when n is equals to 0. Correct? Next, for the angle 30, 60 will be an allied angle. Why? 30 plus 60 is 90. 90 is a multiple of 90. So for any angle theta, an angle alpha is said to be an allied angle only if either sum of them or the difference of them is a multiple of pi by 2. Next, we have already gone through these allied angles: sine of 90 plus theta, sine of 90 minus theta, cos of them, sine of them, tan of them, cotangent of them. Just refer to the session again so that you will understand much better. As this is recap, I am just revising it. So depending on quadrants, suppose if for any acute angle theta, every angle in first quadrant will be of the form 90 minus theta. Every angle in second quadrant will be of the form 90 plus theta or even less than 180. more than, in third quadrant, more than 180 or even less than 270. In fourth quadrant, more than 270, less than 360. In first quadrant, more than 360, and the cycle repeats. So sine of 90 minus theta will be lying in first quadrant, and in first quadrant sine is positive, but for odd multiples of pi by 2, sine changes to cos. So we say sine of 90 minus theta is cos theta. Whereas tan of 90 plus theta, tan of 90 plus theta, 90 plus theta is in second quadrant. Second quadrant, tan is negative, so we put minus. Now for 90, that is odd multiple of 90, tan changes to cot. So tan of 90 plus theta will be minus cot theta. That's how we get the remaining also. Next, decoding sine of n pi plus or minus theta, cos n pi plus or minus theta, tan n pi plus or minus theta. In all these cases, what we do, friends, if you observe one thing, on x-axis, angle starts from 0 here, 0, pi by 2, pi, 3 pi by 2, 2 pi. So 0, pi here, 2 pi here, 3 pi here, 4 pi here. So if you observe one thing, all odd multiples of pi will be coming here and all even multiples of pi will be coming here. If you go in clockwise direction also, odd multiples of pi, again even multiples of pi. Okay. So by this conclusion we can do one thing. Any angle in second, here we are having odd pi, correct? Here we are having even pi. So less than this, less than odd pi will be in second quadrant. More than odd pi will be in third quadrant. Greater than even pi will be in first quadrant. Less than even pi will be in fourth quadrant. Now by using this, any angle which is of the form odd pi minus theta, odd pi minus something will be in second quadrant. Odd pi plus theta will be in third quadrant. Even pi plus theta will be first quadrant. Even pi minus theta will be in fourth quadrant. Now by using this, suppose if you see a sine of 37 pi by 3, 37 pi by 3 or any. By using this decoding, first nearest multiple of 3 in 37 is, near to 37 we have 36. So this 37 we can write it as 36 pi plus pi whole divided by 3. So sine of 36 by 3 is 12 pi plus pi by 3. Now sine of even pi plus theta, which is in first quadrant. So that becomes sine pi by 3 and the value of sine pi by 3 is root 3 by 2. So that's how we get sine n pi plus or minus theta, cos n pi plus or minus theta, tan n pi plus or minus theta. If we just remember these three, then we'll get entire allied angles concept. Next. So that's it regarding ratios, friends. Now we are in compound angles. So for any given angles, capital A comma capital B, sine of A plus B is sine A cos B plus cos A sin B. Already we proved it in our regular sessions. So as it is recap, I'm just going through the formula. Sine of A plus B, sine A cos B plus cos A sin B, sine of A minus B, sine A cos B minus cos A sin B, cos of A plus B, cos of A minus B, tan of A plus B, tan of A minus B, cot of A plus B, cot of A minus B. These are the formulae that you should be thorough with. Clear? Next, when you know sine of A plus B and sine of A minus B, sine of A plus B we know, sine of A minus B we know. When you multiply this, sine of A plus B is sine A cos B plus cos A sin B, and sine of A minus B sine A cos B minus cos A sin B. Then you get sine A cos B whole square minus cos A sin B whole square. So if you simplify this, that means expressing in terms of one trigonometric function, either sine or cos. If you wish to express in terms of sine, then you get sine square A minus sine square B. If you wish to express in terms of cos, cos square B minus cos square A. So sine of A plus B into sine of A minus B is either sine square A minus sine square B or cos square B minus cos square A. In the same way, cos of A plus B into cos of A minus B is cos square A minus sine square B, or even cos square B minus sine square A. So So this is how, like, these two are important with respect to compound angles. Next, if we go with compound angles for three angles, sin of a plus b plus c, cos of a plus b plus c, tan of a plus b plus c. To prove them, proving part is simple, because anyhow we know sin of a plus b, sin of a plus b is sin a cos b plus cos a sin b. Now in getting sin of a plus b plus c, we just take b plus c as one particular angle and we use sin of a plus b now. Sin a into cos, in place of b we can write b plus c, and again we know how to expand cos of b plus c. So if we just expand it, we get it. Proof is not important. Remember the formula, friends. Okay, when you are remembering the formulae, try to analyze a particular pattern in it and then remember accordingly. Okay, see, sin of a plus b is, see, one sin, then remaining 2 cos, one sin remaining 2 cos, one sin remaining 2 cos. So sin a into cos b cos c plus cos a into sin b cos c plus sin c cos a cos b into sin c. Now these three ho gaya. Next, last we end up with minus sin a sin b sin c. Whereas in cos, we start with cos a cos b cos c, one cos remaining 2 sins in subtraction. Clear? Next, tan of a plus b plus c can be written as sigma tan a minus pi tan a. Sigma means summation, pi means product. Pi means not the number, friends. Pi is function. Pi tan a means tan a into tan b into tan c, whole divided by 1 minus sigma tan a tan b. So tan of a plus b plus c, which is only this particular thing is important. Tan of a plus b plus c is tan a plus tan b plus tan c minus tan a into tan b into tan c, whole divided by 1 minus tan b, 1 minus tan a tan b minus tan b tan c minus tan c tan a. Next, if the angles extend, if we express it for more angles, then we get this, not necessary at all. Next, transformation formula. Transformation formula means we use it to express or to change from sum to product or product to sum. Now first thing is product to sum. Friends, we have sin of a plus b, sin of a minus b. If we add them, sin of a plus b plus sin of a minus b. In sin of a plus b, we have sin a cos b plus cos a sin b. In sin of a minus b, we have sin a cos b minus cos a sin b. So when you add them, plus cos a sin b minus cos a sin b gets cancelled. You get 2 sin a cos b. So that is 2 sin theta. So whenever you come across a product of sin and cos, then you will be using this. 2 sin a cos b is sin of a plus b plus sin of a minus b. 2 cos a sin b, sin of a plus b minus sin of a minus b. 2 cos a cos b, cos of a plus b, cos of a minus b. And 2 sin a sin b is, just remember the change, cos of a minus b minus cos a plus b. Next, sum to product. First we have discussed product to sum. Now sum to product. Formula to transform sum or difference into product. Number 1, sin c plus sin d is 2 sin c plus d by 2 into sin c minus into cos c minus d by 2. Sin c minus sin d is cos into sin. Cos c plus cos d both cos, cos c minus cos d both sin. This can also be written as minus 2 sin c plus d by 2 into sin c minus d by 2. Check properly whether are we writing d minus c by 2. If you are writing d minus c by 2, then no negative here. If you are not writing d minus c by 2, then if you are writing only c minus d by 2, then put minus here. So these two are transformation formulae. Next, trigonometric ratios for multiple and submultiple angles. First we go with multiple angles. Sin 2 theta. We know sin of a plus b. Put a theta and even in place of b also put theta. Then you get sin of theta plus theta, which is sin 2 theta. Sin 2 theta. Then we get 2 sin theta into cos theta. It can also be expressed in terms of tan as 2 tan theta by 1 plus tan square theta. Majority of the students are asking me, sir, how it is? We have 2 sin theta cos theta by 1. That 1 we can write it as sin square theta plus cos square theta. Now divide both numerator and denominator by cos square theta. So you get numerator 2 sin by cos, which is 2 tan theta, divided by cos square by cos square, which is 1, plus sin square by cos square is tan square theta. So sin 2 theta can be expressed in terms of sin and cos, and even only in terms of tan also. In the same way, cos 2 theta, cos square minus sin square, which is 2 cos square theta minus 1, or 1 minus 2 sin square theta, or 1 minus tan square by 1 plus tan square. Next, these two are the most important formula. Even we use it in calculus also. By the time you come across this particular formula, you will be understanding the value of it. We have seen many calculus questions, whether it is in differentiation or even integration. We use this. 1 plus cos 2 theta is equals to 2 cos square theta. 1 minus cos 2 theta will be 2 sin square theta. Very important. And these two not that much. This one not that much. Then tan 2 theta, which is 2 tan theta divided by 1 minus tan square theta. Next, multiple angles for 3. Sin 3 theta is 3 sin theta minus 4 sin cube theta. Cos 3 theta 4 cos cube theta minus 3 cos theta, and tan 3 theta is 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. How we got it? Already we know sin of a plus b plus c, cos of a plus b plus c, and tan of a plus b plus c. In that, just put a equals to b equals to c equals to theta, then we get sin 3 theta, cos 3 theta, tan 3 theta respectively. Next, most important things, friends, there are some, we already know standard angles like 0, 30, 45, 60, 90 and all the allied angles of them. Apart from that, in those standard angles, we are also supposed to include this also. 18, 72, 36, 54, 20, 24.5, all these things, okay, starting with sin 18 degree. All these things we have proved in the class itself. So I am just collecting all the values at one place so that it will be easy for revision. Starting with sin 18, root 5 minus 1 by 4, cos 36, root 5 plus 1 by 4, conjugates. Sin 72, square root of 10 plus 2 root 5 by 4, sin 36, square root of 10 minus 2 root 5 by 4, or we say cos 18. Next, sin 15, root 3 minus 1 by 2 root 2, cos 15, root 3 plus 1 by 2 root 2. Tan 15 is sin 15 by cos 15. When you rationalize that with the, when you rationalize the denominator, then we get 2 minus root 3. Tan 75 or cot 15, which is 2 plus root 3, and tan 22.5 is root 2 minus 1, cot 22.5 is root 2 plus 1. Next, cot pi by 24, or we say cot 7.5. This question was asked in JEE directly, like what is the value of cot 7.5 degree or cot pi by 24? It is root 2 plus root 3 plus root 4 plus root 6. Just remember the values. Next, conditional trigonometric identities. Already in the beginning of the lecture, we have seen 3 trigonometric identities. They are true for all theta. I mean, for all the theta belongs to the complete domain of the given functions, it is true. So that's the reason why we call them as identities. But these are called conditional trigonometric identities, means they are not going to true for every theta. They are only going to be true for theta belongs to so and so. So, if a plus b plus c is equals to pi, then sin 2a plus sin 2b plus sin 2c is equals to 4 sin a sin b sin c. In grade 11, we might have proved these as like proofs of long answer type questions. We were having prove sin 2a plus sin 2b plus sin 2c is equals to 4 sin a sin b sin c if a plus b plus c is equals to pi. We might have proved it. Yes, we have already proved it, but just remember it as a formula now. So sin 2a plus sin 2b plus sin 2c is 4 sin a sin b sin c. Next, sin a plus sin b plus sin c is 4 cos a by 2 cos b by 2 cos c by 2. Proof is also simple, friends. We can use sin c plus sin d form. We can use sin c plus sin d form, and sin 2c can be written as 2 sin c cos c. So from there, just by taking the concerned terms common, then just simplifying it, we will be getting it. Proof is not much important. Do not care about the proof. Proof is only for understanding. It's time to memorize. Remember the formula. Always remember the formula with a particular pattern. Next, these are the 8 conditional trigonometric identities. Among them, the most important is when a plus b plus c is equals to pi or a multiple of pi, then sigma tan a is equals to pi tan a. Sigma tan a is equals to pi tan a, and sigma tan a by 2 tan b by 2 is 1. Next, sigma cot a by 2 is equals to pi cot a by 2. Sigma cot a cot b is equals to 1. These 4 are very important. We use them very frequently. Among these 4, these 2 are very important. If a plus b plus c is a multiple of 5, then Tan A plus tan B plus tan C is always equals to tan A into tan B into tan C. Next, most useful series that we have, whenever you come across sine series in addition, cosine series in addition, that too angles in arithmetic progression, friends. Angles should be in arithmetic progression. See, alpha plus beta, alpha plus 2 beta, alpha plus 3 beta. This is general form of an AP. Here also alpha plus beta, alpha plus 2 beta, and so on, alpha plus n minus 1 into beta. General form of an AP. So whenever you come across sine and cosine series where angles are in the form of AP, then in that case we use sine and cosine series. We call them as sine and cosine series, and remembering them is also very simple. For both it is sin n beta by 2, sin n beta by 2, numerator. Denominator is sin beta by 2, sin beta by 2. Here what is the beta? Beta is the common difference of the AP, common difference of the angles. Next, so nth term already we know A plus n minus 1 into D. Here common difference actually it is beta, just take it as beta by 2. So it is alpha A plus n minus 1 into beta by 2. Okay, so sin n beta by 2 by sin beta by 2 is same for both, and for sin it is only sin, and for cos it is cos. The only difference between these two is sin, for sin angle it is sin, for cos angle it is cos. Everything else will be same. Clear? Next, product of cosine series. We have product of cosine series only for cosine, not for sine. So in this case what we do, cos theta into cos 2 theta, whenever if you have a GP, whenever we have a GP with first term 1, like first term can be anything, all you see, integral powers of 2, cos 2 power 0 into theta, cos 2 power 1 into theta, cos 2 square theta, cos 2 cube theta, and so on, cos 2 power n minus 1 into theta. Remember how many number of terms? Okay, so that is equals to sin 2 raised to how many number of terms? N divided by 2 power n into sin theta. Here n denotes number of terms. Here n denotes number of terms. Clear? Suppose imagine we have started a series from cos 2 power 5 into theta, cos 2 power 6 into theta, cos 2 power 7 into theta, and we end up with cos 2 power 8 into theta. So here n is not 8, friends. Here n denotes only number of terms, number of cosines are in multiplication, 1, 2, 3, 4. So we write it as sin 2 power 4 into theta divided by 2 power 4 into sin theta. So that's how we do. Clear? Next, graphs of trigonometric functions. I have already given a clear explanation of graphs in the session. I urge you to go with sine, cos, tangent. These three are enough. Sine graph, tan graph, and cosine graph. Clear? Next, range of trigonometric functions. Domain and range we'll see. Y is equals to sin x. The domain of this function is, domain for sine function is x belongs to capital R, and range is y belongs to closed minus 1 comma 1. Whereas for y is equals to cos x, domain is same, range is also same. For y is equals to tan x, domain is tan x is sin x by cos x. So we have to include only the values of x such that cos x cannot be 0. When will cos x be 0? For all odd multiples of pi by 2. So we exclude that, r minus of 2n plus 1 into pi by 2. Friends, remember one thing. For secant x and tan x, domain will be same. So for secant x also, r minus of odd multiples of pi by 2. Next, for cot x and cosecant x, domain will be same again. X belongs to r minus. Cot x is cos by sin. So when will cos be 0? For all multiples of pi. So r minus of n pi, and even in this case r minus of n pi. For in all the cases n belongs to capital Z. Now coming to the range of tan and cot. Tan and cot range is set of real numbers, whereas secant and cosecant range is r minus of excluding all the values in between minus 1 and plus 1. So these are the range and domain of all the 6 trigonometric functions that we have. Next, range of the function which is of the form a sin x plus b cos x. I also add a c also. Suppose e is equals to a sin x, either it is plus or minus, anything is fine, plus b cos x plus c. The minimum value of this is, friends, the minimum value of this is c minus of square root a square plus b square, and maximum value of this is c plus square root of a square plus b square. So range will be now e minimum to e maximum. Clear? If there is no c, then it will be only minus root a square plus b square to plus root a square plus b square. So friends, with that we are done with the complete trigonometry. Next, this chapter is properties of triangles. Also some read it as solutions of triangles. So whatever you read it, no issues. Now entering into properties of triangles. Again, even in properties of triangles also, formulae part only. Only formulae. We start with the cosine rule. Cosine formula or cosine rule, it gives the relationship between sides and angles of the triangle, friends. Okay. So cos A is equals to, we have a standard notations in complete properties of triangles. Capital A, capital B, capital C denotes angles. Small a, small b, small c denotes the sides opposite to the respective angles. Small a denotes the side which is opposite to capital A. Small b denotes the side which is opposite to capital B, angle B. And small c denotes the side which is opposite to angle C. Now, in this case, cos A is equals to b square plus c square minus a square divided by 2bc. We can remember this. There is one good thing with respect to properties of triangle formulae. All the formulae can be remembered by using symmetry, friends. See, A, so only minus a square, B minus b square, C minus c square. Except C, the remaining a square plus b square minus c square by 2ab. And also we have a square is equals to b square plus c square, a square is equals to b square plus c square minus 2bc cos A. From here, b square is equals to c square plus a square minus 2ac cos B. In the same way, c square is equals to a square plus b square minus 2ab cos C. So this can also, when sides are given, to know the angles, we use this. When angle is given, when two sides and the included angle is given, to get the unknown side, we use these particular either of the three formulae. Next, projection rule. Projection rule means to express A in terms of only angle B, angle C and sides B and C, then we use projection formulae. A is equals to B cos C plus C cos B, B is equals to C cos A plus A cos C, C is equals to A cos C, A cos B plus B cos A. These three are the projection formulae. Next, sine rule. In any triangle, sine rule and cosine rule means these two rules gives the relationship between sides and angles of the triangle, friends. Okay, so in any triangle ABC, A by sin A is equals to B by sin B is equals to C by sin C is equals to some constant. This constant is equals to twice R, where R is the circumradius. Where R is circumradius. What do you mean by circumradius? It is the radius of the circle passing through the three vertices of the triangle. That is radius of circumcircle. So in any triangle, A is equals to 2R sin A, B is equals to 2R sin B, and C is equals to 2R sin C. So that is what we say, A by sin A is equals to B by sin B is equals to C by sin C, or even reciprocal will also be same. Sin A by A is equals to sin B by B is equals to sin C by C. Majority of the case we use this formula, friends. Next, half angle formula, which are very important actually. So how do we get it in general? How do we get it? We already have, see, cos A is equals to, B square plus C square minus A square divided by 2BC. Now, we know cos 2 theta is equals to 2 cos square theta minus 1. So this we can write it as in the same way, 2 cos square a by 2 minus 1 is equals to b square plus c square minus a square divided by 2bc. So from here 2 cos square a by 2 is equals to, take minus 1 to that side, then it becomes plus 1. So we get b square plus c square minus a square plus 1 no, when we take LCM, plus 2bc divided by 2bc. Now b square plus c square plus 2bc is b plus c whole square. So 2 cos square a by 2 is equals to b plus c whole square minus a square divided by 2bc. b plus c whole square is, so now this is of the form clearly something x square minus y square, x plus y into x minus y. So that is a plus b plus c into b plus c minus a divided by 2bc. Now I will give you this. Friends, we all know S is semi-perimeter. S is semi-perimeter and 2S is equals to A plus B plus C. Okay. So now A plus B plus C is 2S. Yes, 2 gets cancelled. We get S into B plus C minus A. This B plus C minus A, when you add and subtract A, so this we can write it as A plus B plus C minus 2A. A plus B plus C is 2S. 2S minus 2A. S common. So you get 2 of S minus A divided by BC. And this is equals to 2 cos square A by 2. 2 cancel. So finally friends, cos square A by 2 is equals to S into S minus A divided by BC. From here we get cos A by 2 is equals to square root of S into S minus A divided by BC. Once you know cos square A by 2 plus sin square A by 2 is 1. By using that we get sin A by 2. And once you know sin and cos, tan A by 2 will be sin A by 2 by cos A by 2. And by using grade 9 Heron's formula, we know area of any triangle is always equals to square root of S into S minus A into S minus B into S minus C. By using that, we can get in terms of delta also. Clear? So these three are half angle formulae, sin A by 2, cos A by 2, tan A by 2. If you remember one pair friends, then we can get the remaining just by using symmetry. See, for cos A by 2, it is S into S minus A by BC. Cos B by 2, S into S minus B by CA. Cos C by 2, it is cos C by 2. It is cos C by 2. Sin B by 2, cos B by 2, it is and tan C by 2. That's it. So these are the three formulae that we have in half angle formulae. Clear? And already I said delta is square root of S into S minus A into S minus B into S minus C, which is Heron's formula that we discussed in grade 9 itself. So by using that, we can express it in terms of delta also. Next, Napier's analogy, or we say tangent rule. So even this formula can also be remembered by using symmetry friends. You see B minus angle B minus angle C, so side B minus side C, that's it. And left hand side we have B and C, so the remaining will be cot of A by 2. So tan of B minus C by 2 is equals to B minus C by B plus C into cot A by 2. Proving is also so simple, just take B minus C divided by B plus C. Now from sine rule, B is 2R sin B, no? So just take 2R of sin B minus sin C divided by 2R of sin B plus sin C. 2R gets cancelled. Now you can use sin C minus sin D, sin C plus sin D, and then by simplification you will get it friends. Okay. So three formulae from Napier's analogy. If you remember one, you will get the other two. Next, area of the triangle. Different formulas which can be expressed delta. So one formula is delta is equals to square root of S into S minus A into S minus B into S minus C. Next, this we can also write it as half into BC sin A. When you know two sides and included angle, area of the triangle is half BC into sin A, half CA into sin B, half AC into half AB into sin C. So these three, when you know altitudes, then directly half into AP1, half BP2, half CP3, where P1, P2, P3 are the altitudes of the triangle when with respect to the vertices ABC respectively. Next, radius of the circumcircle. Generally, friends, circumcircle means a triangle which passes through the vertices of any triangle. So the circle which is passing through vertex A, B, C is called as circumcircle, and the center of this circle is called as circumcenter. So if generally we denote circumcenter with S, friends. Generally we denote circumcenter with S. This is equidistant from all the three vertices. SA is equals to SB is equals to SC is equals to R. Next, what else we can say? And this S is generally circumcenter is the point of intersection of perpendicular bisectors. Perpendicular bisectors of the sides of the triangle. Sides of the triangle. Where S is circumcenter, S will be the point of intersection of perpendicular bisectors of the sides. So for each side, if you draw perpendicular bisector, these three are concurrent and the point of intersection of those three perpendicular bisectors will be S, and that is what we say circumcenter. Clear? Generally circumcenter S, it is denoted by capital S, whereas small s is semi-perimeter. And the distance from circumcenter to any vertex is called as circumradius. Next, circumcenter, as we already said, A is equals to 2r sin A, B is equals to 2r sin B, C is equals to 2r sin C, and also R can also be written as ABC divided by 4 delta. By using this, we can get capital R value. Next, radius of the incircle, friends. What is incircle? First, the point of intersection of angular bisectors. The point of intersection of angular bisectors. POI of angular bisectors is in center, capital I. Okay, and the perpendicular distance from incenter to any side, the perpendicular distance from I to any side of triangle is called as in radius, which is denoted as small r. Small r means in radius, friends. There are very few years with this particular concept asked in JEE. I generally don't recommend this, but okay, let's have an idea on this. Okay, small r denotes the in radius, and point of intersection of angular bisectors is denoted as capital I. I is in center, friends. I is in center. Next, distance from in center from any side is called in radius. So R is equals to delta by S, different formula that we have. R is equals to delta by S, S minus A into tan A by 2, S minus B into tan B by 2, S minus C into tan C by 2. Last, we have 4R sin A by 2, sin B by 2, sin C by 2. The most important formula that we have is R is equals to 4R times sin A by 2, sin B by 2, sin C by 2. Friends, in general, in any triangle, capital R will always be greater than or equals to 2R. Capital R will always be greater than or equals to 2R, but in equilateral triangle, equilateral triangle means all the angles 60, no? So sin 60 by 2, sin 30 into sin 30 into sin 30, 4, so small r will be equals to 4r into 1 by 8, which is r by 2. So clearly capital R is equals to 2r, capital R is equals to 2r in equilateral triangle, and in the remaining triangles it will be only greater than 2r. Capital R greater than 2r in all the triangles except equilateral triangle, whereas in equilateral triangle capital R will be equals to 2r. This is the only concept which is important from this. Next, regular polygon. We consider regular polygon in two cases. Regular polygon means a polygon of n sides where all the n sides are equal. Okay. So if all the n sides of a regular polygon are equal, then it is regular polygon. If a regular polygon is inscribed in a circle, inscribed, so it is lying inside the triangle, okay, inside the circle. Now in this case, what will be the side length of the polygon? Let's say small a denotes the side length of the polygon, and r, anyhow for circle r is the radius. Now see this, friends, the complete angle will be 2 pi. Complete angle will be 2 pi. So as there are n sides and it is regular polygon, this particular angle will be 2 pi divided by n. 2 pi divided by n, and it is regular polygon. So if we draw a perpendicular from O to one side, this angle will be pi by n, this angle will also be pi by n. Clear? This angle pi by n, this angle will also be pi by n, because it bisects, no? So this angle pi by n, even this angle also pi by n. Now from this triangle, if I use sine pi by n is equals to opposite over hypotenuse. So distance from here to here, it is a by 2 divided by r. So a by 2r is equals to sine pi by n. A is equals to 2r times sine pi by n. The length of side length of a regular polygon which is inscribed in a circle is 2r sine pi by n. Perimeter will be perimeter of the regular polygon, n times that, so that is 2nr into sine pi by n. 2nr into sine pi by n. Clear? Next we have also one more formula which is related to area. Area is equals to half r square n times sine 2 pi by n. So if you know side length, perimeter, area, then that's enough. When polygon is inscribed in the circle, side length will be 2r sine pi by n, perimeter, area. Next, ascribed about a circle, In this case, if you see this, friends, as usual, so let this be center O. Now this is r, okay, this will be a as usual. So half of this will be a by 2. Now, clearly this will be pi by n. In this case, as we know these two, so tan pi by n is equals to opposite over adjacent. So a by 2r is equals to tan pi by n. A is equals to 2r times tan pi by n. Friends, remember these two. If the polygon is inscribed in the circle, then it is side length will be 2r sine pi by n, whereas inscribed about the circle of radius r, side length will be 2r times tan pi by n. So this is regarding properties of triangles. If you are clear with all these formulae, then you can do any question from properties of triangles, friends. Clear? Next, the last part is inverse trigonometric functions. Again, same story. See one thing, friends, all the trigonometry related concepts, trigonometry related chapters, I mean trigonometric ratios or functions, what you say, compound angles, multiple submultiples, transformation formulae, equations, the last one, properties of triangles, and now inverse trigonometric functions. In all these cases, in all these chapters, formulae is important. Now inverse trigonometric functions. Already we have seen functions. In functions we have seen bijective function. Bijective means a function is said to be, if a function is both 1, 1 and onto, then it is bijective. And inverse exists only for bijective functions. Okay. Now trigonometric functions, if you see sine, domain of sine is r and range of sine is closed minus 1 to 1. Now in the original domain of sine, sine is not bijective. That is, sine is not 1, 1. It is onto, but sine is not 1, 1. So to make it bijective, to make the 6 trigonometric functions bijective, what is the first thing that we did is, we have restricted the domains. We have restricted the domains of the 6 trigonometric functions to make them bijective. Okay. So trigonometric functions are bijective only in their restricted domain. Now what are those restricted domains? Ranges, we'll see. Starting with sine inverse function, or you say arc sine function, both are same. Arc sine or sine inverse, both are same. Generally we denote sine inverse as sine power minus 1, arc sine x. So now Sine, when it is mapping from closed minus pi by 2 to pi by 2. Domain of sine is capital R, but we have restricted the domain of sine from minus pi by 2 to pi by 2. Range is as usual, closed minus 1 comma 1. So only this particular function is bijective. So as this function is bijective, there exists its inverse. Inverse is sine inverse will map from closed minus 1 to 1 to closed minus pi by 2 comma pi by 2. So range becomes domain and domains become range for the inverse functions. So these are inverse of trigonometric functions, and hence the reason we call them as inverse trigonometric functions. So first function is in sine inverse, domain minus 1 to 1, range is closed minus pi by 2 to pi by 2. This is domain, range, graph of that. Cos inverse x or arc cos x, domain, range. Range of cos inverse x is closed 0 to pi, graph of that. Domain of tan inverse x, range of tan inverse x from open minus pi by 2 to pi by 2. Domain of cot inverse x, range of cot inverse x, open 0 comma pi. Next, domain of secant inverse x, range of secant inverse x will be, range of secant inverse x is closed 0 to pi minus pi by 2. Closed 0 to pi minus pi by 2. Next, domain of cosecant inverse x, range of cosecant inverse x is closed minus pi by 2 to pi by 2 excluding 0. So these are the domain and ranges of the 6 inverse trigonometric functions, friends. 6 inverse trigonometric functions. Next we will go with properties one by one. First property, sine of sine inverse x will be x only when x belongs to their domain. Sine of sine inverse x will be equals to x, or cos of cos inverse x will be x, tan of tan inverse x x, cot of cot, in any function f of f inverse x will be equals to x only for all the domain of the inverse trigonometric functions. So this is the first property. We call this property as T of T inverse. T of T inverse will be only true for all domain of the inverse trigonometric functions. Next, T inverse of T. This is the most important property of inverse trigonometric functions, friends. Okay, so sine inverse of sine x. First thing is sine inverse of sine x will be equals to x only when if x belongs to closed minus pi by 2 to pi by 2. Sine inverse of sine x will be x only when x belongs to closed minus pi by 2 to pi by 2. In case if x does not belongs to that region, then we remodify the input by using this. Okay, so if it is from minus pi by 2 to pi by 2, same, the function is y is equals to x only. If it is from pi by 2 to 3 pi by 2, it is pi minus x. 3 pi by 2 to 5 pi by 2, it is x minus 2 pi. So by using T inverse of T property, this particular function sine inverse of sine x will be x only if x belongs to closed minus pi by 2 to pi by 2. If x does not belongs to that region, then by using this graph or even by using this particular formula, we get the input. Next, cos inverse of cos x. First, actually cos inverse of cos x will be x only if x belongs to closed 0 to pi. But if x does not belongs to closed 0 to pi, then by either using this or by graph, we can get the input. Tan inverse of tan x, same. So tan inverse of tan x will be equals to x only when if x belongs to open minus pi by 2 to pi by 2. If x does not belong to this particular region, then by using this graph or by using these values, then we can get the required value. Similarly, cosecant inverse of cosecant x or even secant inverse of secant x. Next, property 3, minus x property. This particular property Sin inverse of minus x, tan inverse of minus x, cosecant inverse of minus x are three odd functions and they are symmetric with respect to origin. So as they are odd functions, sin inverse of minus x is minus sin inverse x, tan inverse of minus x is minus tan inverse x, whereas cosecant inverse of minus x is minus cosecant inverse x, friends. Okay. Now the graphs, the functions cos inverse x, secant inverse x, cot inverse x are symmetric about the point 0 comma pi by 2. Symmetric about the point 0 comma pi by 2. Hence cos inverse of minus x is pi minus cos inverse x. Secant inverse of minus x is pi minus secant inverse x. And cot inverse of minus x is pi minus cot inverse x. These three are symmetric with respect to the point 0 comma pi by 2. Whereas these three are symmetric with respect to the point 0 comma 0 origin. How, sir? Just look at the graph, friends. Next, property 4. These three are very important. Sin inverse x plus cos inverse x pi by 2. Tan inverse x plus cot inverse x pi by 2. Cosecant inverse x plus secant inverse x is also pi by 2. Sir, how? Just by converting into trigonometric function and then just by getting it, friends. So already I have given. If we take sin inverse x as A and cos inverse x as B, see, then sin inverse x proof, sin inverse x plus cos inverse x is equals to pi by 2. First let's take sin inverse x is equals to sum A and cos inverse x is equals to sum B. So from here we can say x is equals to sin A, x is equals to cos B. Okay. Now x is equals to, this sin A we can write it as cos of pi by 2 minus A, because cos pi by 2 minus A is sin A. Okay. So now this x is equals to, we already have cos B, that means pi by 2 minus A is equals to B. So A plus B is equals to pi by 2. By using the remaining we can also prove them. Okay. So three most important property for sin inverse x plus cos inverse x pi by 2, tan inverse x plus cot inverse x pi by 2 and cosecant inverse x plus secant inverse x is also pi by 2. Next thing is interconversion. Interconversion of inverse trigonometric functions is very important, and in this we will be knowing how to convert, how to express one inverse trigonometric function to the other. The thing is very simple, friends. Suppose we would like to express sin inverse x in terms of cos inverse as tan inverse. The thing that we do is just write it as some theta. From here we get x is equals to sin theta. Now take one right angle triangle. Now sin theta is equals to x means generally we know sin theta is equals to opposite over hypotenuse. So x by 1. Now this will be under root 1 minus x square. Now from the same from this triangle, what is cos theta? Cos theta will be adjacent over hypotenuse. Tan theta opposite over adjacent. Cot theta root 1 minus x square by x. Now from this we can say theta is equals to cos inverse of root 1 minus x square. Theta is equals to tan inverse of x divided by under root 1 minus x square. So just by using this particular right angle triangle, now you see this, friends. So sin inverse x is equals to theta, no? Now the same theta is equals to cos inverse of under root 1 minus x square. Same theta is equals to tan inverse of x divided by under root 1 minus x square. We can also express in terms of secant inverse, cosecant inverse and even cot inverse also. This is how we use in converting one inverse trigonometric function to the other. Next, property 4. This property is called as reciprocal property. So cosecant inverse x will always be equals to sin inverse 1 by x. Secant inverse x is cos inverse 1 by x. Cot inverse x, only this particular case. If x positive, it is only tan inverse 1 by x. If x is negative, then it is pi plus tan inverse of 1 by x. Next, different identities that you should know, friends. Tan inverse x plus tan inverse y is equals to pi by 2 if x into y is equals to 1. X positive, y positive, x into y is equals to 1. Then tan inverse x plus tan inverse y is equals to pi by 2. Tan inverse x plus tan inverse y is equals to tan inverse of, this is like tan of a plus b, friends. If you know tan of a plus b, tan of a plus b is tan a plus tan b by 1 minus tan a tan b. We just take tan a as some x, tan b as some y. So tan a is equals to x means a is equals to tan inverse x. In that way we get the remaining. So tan inverse x plus tan inverse y is tan inverse of x plus y by 1 minus xy. If x into y is greater than 1, then it is pi plus tan inverse of x plus y by 1 minus xy. Next, tan inverse x minus tan inverse y. Tan inverse x minus tan inverse y is tan inverse of x minus y by 1 plus xy. Sin inverse x plus sin inverse y is sin inverse of x into under root 1 minus y square plus y into under root 1 minus x square. This is only if x square plus y square less than or equals to 1, and this case if it is greater than 1. Sin inverse x plus sin inverse y will be pi minus this if x square plus y square greater than 1. Next, sin inverse x minus sin inverse y is sin inverse of x into under root 1 minus y square minus y into under root 1 minus x square. Cos inverse x plus cos inverse y. Cos inverse x minus cos inverse y. If x is less than y, then we write minus cos inverse. If y is less than x, then we just write cos inverse of xy plus under root 1 minus x square into root 1 minus y square. And next, we have one more simplest formulas regarding sin 2 theta, tan 2 theta, cos 2 theta. In the same way, sin inverse of 2x by 1 plus x square in terms of tan is 2 tan inverse x. X greater than 1, it is pi minus 2 tan inverse x. X less than minus 1, it is minus pi minus 2 tan inverse x. Next, cos inverse of 1 minus x square by 1 plus x square is 2 tan inverse x only if x is positive, minus 2 tan inverse x if x is negative. Next, tan inverse of 2x by 1 minus x square, if mod x belongs to minus 1 to plus 1, it is 2 tan inverse x, and these two cases very rare, friends, very rare. So with that we are done with complete inverse trigonometric functions and even trigonometry and properties of triangles. The final conclusion that I would like to give you is, in these three trigonometry related chapters, the most important thing is formulae. If you are clear with the formulae, then we can do any question from it. Okay, so that's it regarding this particular recap, friends. Wish you all the best for your preparation. See you in the next session. Till then, take care everyone.